And welcome back. As we dive into a little bit more with exceptions today, we're going to start looking at user-defined exceptions. Now, we're not going to go ahead and define those exceptions today, but we want to go ahead and start laying down the framework of how these are going to work. So the first thing we want to talk about, of course, is the exception classes themselves. There are, of course, more exception classes than the single class exception that we have looked at up to this point. The exception class, of course, is in our standard Java library, and of course, we can also have others that we pull in, or we can even define our own. Now, all the exception classes that exist within the Java libraries have, and the exception classes that we define should have, the following properties. First off, we're going to need a constructor that takes a single argument of type string, and that the class has an accessor method called getMessage that can recover the string given as an argument to that constructor when the exception object was created. Ultimately, this is going to come back to the combination of try, throw, and catch. When these different mechanisms are used together, these statements are how we end up throwing and catching our exceptions. The throw statement, which we looked at previously, is what throws the exception. It's the key thing that can trigger it, whether that is done behind the scenes or we explicitly make a throw call. Now, the throw statement is normally included within a try block. That's the most common place you'll see the throw. And then, of course, we use the catch block to catch whatever exception is that we are trying to use. Now, when the exception is thrown, the try block is, of course, going to end, and then the code in the catch block is executed, as we have seen already multiple times. After the catch block is completed, the code in the catch block is executed, provided that the catch block has not terminated the program, such as using system.exit0, or perform some other type of action. If there is no exception thrown, of course, in the try block, as we know, then after the try block is completed, the program execution continues after whatever catch blocks we have. So it just skips them over completely. Now, there are, as I already mentioned, exception classes that exist within the standard packages of the Java libraries. There are numerous different predefined exception classes that are included within the standard packages, and we could go through all of them, but again, there's a whole bunch of them that we're not going to spend a lot of time on. Just know that they do exist, such as things such as the IO exception, no such method exception, or the file not found exception. We've seen, for example, file not found exception when we have done things with file input and output. We want to say, hey, this file is not found. How do we handle this so we don't completely crash everything? Now, the exception class itself is, of course, the root class. It is the base class for all exceptions. And every exception class, therefore, is a descendant of that class. You can use technically the class exception itself, but you are even more likely to use it to define a derived class of the class exception, particularly when we are starting to use our own classes, when we're starting to make our own exception statements. Now, of course, the class exception, as we mentioned before, is in the java.lang package, so we don't have to import that. Now, if we had, for example, other ones like file not found exception is something that we had to import previously because it is not part of the java.lang package, so that is something that's much more specific, even though it's already predefined. And just real quick, again, we haven't gone ahead and looked at making our own exception classes here, but I want to give you a quick example again, just so we can quickly iterate the try, catch, throw mechanism, as well as looking at the exception class. So here, if we look, we have a quick try block that is simply just going to test this variable and see if it has a certain value. If it is greater than 30, we're going to throw an exception. Otherwise, we're going to throw a different exception. Notice it is both of these, though, are technically using the same catch statement. It's calling the exception class. This, of course, is our base class, and it's just passing in a string here. And that string, of course, is just going to be passed into here and be printed out to the console. If there is, of course, nothing to be thrown, then we get no exception. And then lastly, of course, it just says leaving try block. Now notice that there is a after catch block here, which is fine. So let's just go ahead and run this just to see if we start getting some values. So when I plug this in as is, this is 46. 46 says try block entered. Boom, we know we're here inside of our try block. And it says it's over 30. So if we look here, this says throw new exception over 30. And then, of course, it catches that exception. Now, if we were to change this wait time, so for example, let's just go ahead and make this 30. And then we rerun our program, you'll see that now says no exception because it tested the if, didn't meet that, tested the else if, didn't meet that. So neither of these exceptions were thrown. And so we just get this else statement. We get the leaving try block line here because, again, there has been no exception thrown, so it's just going to continue with program execution until it reaches the end of the try block. Skips over the catch block because, again, no exception has been thrown, and then it's just going to print out after catch block.